Hello students, today we'll do chapter 7th of NCERT, that is coordinate geometry. Now you have studied in class 9th that to locate any point in a plane we require a pair of coordinate axes. Now here these coordinate axes are x-axis and y-axis. Now to locate the distance of a point from the y-axis, suppose we are taking a point 3 2. Here it is point 3 2 3 2. Now the distance of the point from the y-axis, that is 3 units here, is called x coordinate or abscissa, and the distance of the point from the x-axis, that is 2 units here, is called y coordinate or ordinate. Now any point on the x-axis, suppose here we are taking a point of x-axis as 2 0, any point on the x-axis is of the form x 0, that means the distance of the point from the y-axis is x, and here it is 2 here, it will be of the form 2 0, and distance from the x-axis is 0. Now similarly, any point on the y-axis, here I am taking this 0 3, will be of the form 0 y, where distance of this point from the, as you see, distance of the point from the x-axis is 3 units and distance from the y-axis is 0 units, so it will be of form 0 y. Now how to find the distance between two points? Now distance between 2 points P x1 y1 and Q x2 y2, or you can say the line segment, length of the line segment PQ is given by PQ equal to root of x2 minus x1 whole square plus y2 minus y1 whole square, where x1 and y1 are the coordinates of point P and x2 and y2 are the coordinates of point Q. Now in exercise 7.1, in first question, we have to find the distance between the pair of points. I am doing second part of it. Here 2 points -5 7 and -1 3 are given to us, and we have to find distance between these 2 points. I have taken the points as P and Q. So distance between P and Q will be given by PQ equal to x2 minus x1 whole square plus y2 minus y1 whole square, and that will be here x1 y1 are the coordinates of P and x2 y2 are the coordinates of Q. So here x2 minus x1 will be -1 minus -5 whole square, and plus y2 minus y1 will be 3 minus 7 whole square, and this will give us -1 plus 5 plus -4 whole square. Now -1 plus 5 will be equal to 4, and the square of 4 will be 16, and the square of -4 will be equal to 16, that will be under root 32, and that will be 4 root 2 units. So distance between points P and Q is equal to 4 root 2 units. Second question is same as question number 1. Now in question number 3, we have to determine whether the points 1 5 2 3 and -2 -11 are collinear or not. Points A, B and C are given to us. We have to check whether they are collinear or not. For that, we will find out the distance between AB, BC and AC. Now AB, as we know by distance formula, we can say that AB will be equal to under root x2 minus x1 square plus y2 minus y1 square, where x1, y1 are the coordinates of A and x2, y2 are the coordinates of B, and that will be equal to 2 minus 1 square plus 3 minus 5 square, and that will give us AB as root 5. Now BC. In case of BC, we will take x1, y1 the coordinates of B and x2, y2 as the coordinates of C, and that is giving us BC as 2 root 53 units. Similarly, in AC, we will take x1, y1 the coordinates of A as x1, y1 and coordinates of C as x2, y2 in the formula, and that is giving us AC equal to 5 root 53. Now, as we see here, if the three points A, B, and C are collinear, if AB plus BC is equal to AC, but as we see here, AB plus BC is not equal to AC. That means given points or points A, B and C are not collinear. Now in question number 3, the vertices of triangle are given to us. Suppose we are taking it as vertex A, B and C, then we have to check whether these are the vertices of isosceles triangle or not. For that, first of all, we will find out AB, BC and AC by distance formula. If any of these two sides, AB, BC or AC, are equal, then we can say that the given vertices are the vertices of a isosceles triangle. Now in question number 6, name the type of quadrilateral formed, if any, by the following points and give reason for your answer. Now in this question we will use some properties of quadrilateral. Now in case both pair of opposite sides of a quadrilateral are equal and diagonals are not equal, then we can say that it is a parallelogram. Now if both pair of opposite sides are equal and diagonals are also equal, then that quadrilateral will be a rectangle. Now in case of rhombus, all sides will be equal and diagonals are not equal, and in case of square, all sides are equal and diagonals are also equal. Now in second part of question number 3, we have to check that whether A minus 3 5, B 3 1, C 0 3 and D. Now here the vertices of a quadrilateral are given to us. We have to check that which type of quadrilateral it is. Now for that, now I am drawing a rough diagram of the quadrilateral, that is ABCD. Now we will find out, first of all we will find out the sides of the quadrilateral and then the diagonals of a quadrilateral. Now if we see here, side AB by distance formula will be equal to under root x2 minus x1 square plus y2 minus y1 square. Here x1 y1 will be the coordinates of A and x2 y2 will be the coordinates of B. So here it will be 3 minus 3, that will be 3 plus 3 square plus 1 minus 5 square, and that will be equal to 3 plus 3 will be 6 and square of 6 is 36. Again 1 minus 5 will be equal to 4 and square of minus 4 will be 16. That will be root 52, and that can be written as 2 root 13 units. Now similarly we can find BC, CD and AD. by distance formula. Now here any of the two sides are not equal. Therefore, first of all, we will check whether this is forming a quadrilateral or not. For that, we will find out a diagonal AC. Now, AC will be equal to 0 plus 3 square and plus 3 minus 5 square, and that equal to under root 9 plus 4, and that is root 13. Now, as we see here, AC is equal to root 13, AB was 2 root 13, and BC was equal to root 13. Now, for any triangle, in order to form any triangle, the sum of the two sides should be greater than the third side. But here, the sum of these two sides, AC plus BC, is not greater than AB, or you can say is less than AB. Thus, ABC, triangle ABC cannot be formed, or you can say ABC is not a triangle. ABC is not a triangle, and if ABC is not a triangle, then we can say that ABCD is not a quadrilateral. So we can say ABCD is not a quadrilateral, or the given vertices are not the vertices of a quadrilateral. Now, in third part of question third, the vertices of a quadrilateral are given to us. Now, first of all, we will find out the sides of the quadrilateral, that is AB, BC, CD and AD, by using the distance formula. Now, and then we will find out the diagonals of a quadrilateral, that is AC and BD. Now here we are getting side AB as root 10 units, BC as root 18 units, CD as root 10 units and AD as root 13. AD is root 18 units. Now, diagonals of a quadrilateral, AC is equal to 2 units and BD is equal to 2 root 13 units. So, as we see here, as sides AB is equal to CD, and that is root 10 units, and BC is equal to AD, and that equal to root 18 units, and diagonals AC is not equal to BD. So, the given vertices are vertices of, now here opposite sides are equal. AB is equal to CD. That means here AB is equal to CD and AD is equal to BD. And diagonals AC and BD are not equal. So we can say that this is a parallelogram. In question number 7, we have to find a point of x-axis which is equidistant from the points 2, minus 5 and minus 2, 9. So let us take a point of x-axis P as x0, as P lies on x-axis, so its y-coordinate will be 0. And this is equidistant from A 2, minus 5 and B minus 2, 9. That means this point P is equidistant from point A and point B. That is PA will be equal to PB. PA is equal to PB, and that means this will be under root. Now PA will be 2 minus x square plus minus 5 minus 0 square, and that is equal to under root. Now PB will be minus 2 minus x square plus 9 minus 0 square. Now this will be on squaring both sides. We will get this as 4 minus 4x plus x square plus square of minus 5 will be 25. That equal to minus 2 minus x square. Now minus 2 minus x whole square can be written as minus 1 into 2 plus x whole square, and square of minus 1 will be 1. That means this will be equal to 2 plus x whole square. So this will be 4 plus 4x plus x square by the formula a plus b whole square equal to a square plus b square plus 2ab. Plus square of 9 will be 81. Here x square and x square will cancel out. This will be minus 4x plus 29 will be equal to 4x plus 85 minus 8x will be equal to, and this is giving x equal to minus 7. Thus the required point is minus 7, 0, as we have got the value of x as minus 7. Now in question number 8, we have to find the value of y for which the distance between P and Q is 10 units. Now here point P and Q are given to us and distance between PQ is 10 units. That means PQ is equal to 10. Now by applying distance formula, now this PQ will be 10 minus 2 square plus y minus 3 square, and that will be y plus 3 square, and that equal to 10. On squaring both sides, now this will be 10 minus 2, that is 80 square plus y plus 3 square equal to square of 10 will be 100. Now we can solve it to find out the value of y. In question number 9, if Q is equidistant from P and R, find the value of x. That means QP is equal to QR. This can be solved as we have solved question number 7. And from this we will get the value of x. Now also find distance QR and PR. Then after finding the value of x, we can easily find the value of QR and PR. Now write the relationship between x and y such that the point xy is equidistant from the point 3, 6 and minus 3, 4. That means if we are taking this point as P and 3, 6 as A and minus 3, 4 as B, then PA will be equal to PB, and from this we can find the relationship between x and y. Here we doesn't have to find the values of x and y, we have to only find the relation between x and y. Now the second topic, or you can say second formula in this chapter, is section formula. Suppose point P divides join of A x1 y1 and B x2 y2 in ratio m1 ratio m2, then coordinates of P, that means the join of A and P is divided by P in ratio m1 m2, then coordinates of P will be equal to m1 x2 plus m2 x1 on m1 plus m2 and m1 y2 plus m2 y1 upon m1 plus m2. Now if P is midpoint of AB, that means m1 is equal to m2, that equal to 1. Then coordinates of P will be equal to x1 plus x2 upon 2 and y1 plus y2 upon 2. In second question of exercise 2, find the coordinates of point of trisection of a line segment joining 4, minus 1 and minus 2, minus 3. Here suppose point P and Q divide a join or trisect join of A 4 1 and 4 minus 1 and minus 2 minus 3, then this P trisect means divide into 3 equal parts. Then here we can say P divides join of AB in ratio. Now here previous to P there is one part, and after P there are two parts. So P divides AB in ratio 1:2. Ratio 1:2. The coordinates of P will be equal to m1 x2 plus m2 x1 upon m1 plus m2, comma m1 y2 plus m2 y1 upon m1 plus m2. Here m1 is equal to 1 and m2 is equal to 2. x1 y1 and x2 y2 are the coordinates of points A and B respectively. Thus we can say that coordinates of P will be equal to 1 into minus 2 plus 2 into 4 upon 1 plus 2 and 1 into minus 3 plus 2 into minus 1 upon 1 plus 2, and that is giving us P as 2 comma minus 5 by 3. Now coordinates of Q can be obtained in two ways. Now Q divides join of AB in ratio 2:1, or we can say that this Q is midpoint of PP. So coordinates of Q will be equal to x1 plus x2 upon 2, y1 plus y2 upon 2, where x1, y1 are the coordinates of P and x2, y2 are the coordinates of B, as Q is midpoint of PB. So it will be, so this will be equal to 2 plus minus 2 upon 2 minus 5 by 3 plus 3 upon 2, and this will give us coordinate of Q as 0 comma 2 by 3. Thus point 2 minus 5 by 3 and 0 2 by 3 divide the join of AB in 3 equal parts or trisect the join of AB. In fifth question, find the ratio in which a line segment joining A 1 minus 5 and B minus 4 5 is divided by x-axis. Also find the coordinates of the point of division. Now suppose point of x-axis P x0 divides a join of A 1 minus 5 and B minus 4 5 in ratio k:1, then coordinates of P here will be given by k into m1 x2 plus m2 x1 upon m plus m2 and m1 y2 plus m2 y1 upon m1 plus m2. That will be k into minus 4 plus k plus 1 into 1 upon k plus 1 and k into 5 plus 1 into minus 5 upon k plus 1, and this is equal to minus 4 plus 1 upon k plus 1 comma 5k minus 5 upon k plus 1, and coordinates of P we have taken here as x0 as it is a point of x-axis. Now on equating both sides we are getting x equal to minus 4k plus 1 upon k plus 1 and 0 equal to 5k minus 5 upon k plus 1. Now on solving this 0 equal to 5k minus 5 upon k plus 1, we are getting k equal to 1. Now on putting the value of k equal to 1 in x equal to minus 4k plus 1 upon k plus 1, we are getting x as 5 by 2. So the required point, that was P here and that was x0, will be 5 by 2 comma 0, and the required ratio will be the value of x and here value of value of k, and here the value of k is equal to 1. So its required ratio is 1:1. That means this point P is midpoint of AB. In question number 6, if 1, 2, 4y, x6 and 3, 5 are the vertices of parallelogram taken in order, find x and y. Now taking the vertices of parallelogram as A, B, C, D, we know that the diagonals of parallelogram bisect each other. That means this midpoint of AC, I am taking it here as O, the midpoint of AC will be equal to midpoint of BD. Midpoint of AC will be 1 plus x upon 2, comma 2 plus 6 upon 2. And midpoint of BD will be 4 plus 3 upon 2 plus 5 plus 5 upon 2. And on equating both sides, on equating the coordinates on both sides, we can find the value of x and y. In question number 8, if A, B are minus 2, 2 and 2 minus 4 respectively, find the coordinates of P such that AP equal to 3 upon 7 AB and P lies on a line segment AB. Now here P lies on a line segment AB and AP is given to us as 3 by 7 AB. Now that means BP will be equal to AB minus AP, and AP, on putting the value of AP from the first, we are getting PP as 4AB upon 7. Now AP upon BP will be equal to 3 by 4. That is AP ratio PB is 3 by 4. Or we can say that P divides AB, join of AB in ratio 3 ratio 4. Now from here we have obtained M1, M2 and X1, Y1 that are the coordinates of A and X2, Y2 the coordinates of B are given to us. So we can find out the value of P by applying the section formula. Now in question number 10, we have to find the area of the rhombus whose vertices are given to us. Now vertices of rhombus A, B, C, D are given to us. Now we have to find its area. For that, first of all, we will find out diagonal AC and BD by using the distance formula. Now as we know, area of rhombus is equal to half into product of the diagonals. So here area of ABCD will be 1 upon 2 into AC into BD. Now last topic of this chapter is area of triangles. Now area of triangle whose vertices A, x1, y1, B, x2, y2 and C, x3, y3 is given by delta equal to 1 upon 2 x1, y2 minus y3 plus x2, y3 minus y1 plus x3, y1 minus y2. Now we should keep in mind here that the area of triangle is always positive. So here we will take only the positive value of the area of triangle. Now if points A, B and C are collinear, then they will not form a triangle. That means the area of triangle will be equal to 0, or we can say that x1 into y2 minus y3 plus x2 into y3 minus y1 and plus x3 into y1 minus y2 will be equal to 0. Now first question of exercise 7.3, we have to find the area of triangle whose vertices are given to us. I am doing second part of it. Now vertices of triangle ABC are given to us. So area of triangle will be half x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. Here we will take the coordinates of A as x1, y1, coordinates of B as x2, y2 and coordinates of C as x3, y3. Now putting the values of x1, y1, x2, y2 and x3, y3, we are getting the area of triangle ABC as 32 square units. Now in second question, we have to find the value of K if the coordinates of if points A, B and C are collinear. Now if point A, B and C are collinear, then x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2 will be equal to 0. Now on putting the values of x1, y1, x2, y2 and x3, y3, we will get the value of k as 3. In question number 3, we have to find the area of the triangle found by joining the midpoints of the sides of triangle whose vertices are given to us, and we also have to find the ratio of this area to the area of given triangle. Suppose triangle ABC is the given triangle whose vertices are 0, -1, 2, 1 and 0, 3. Now let P, Q and R are the midpoints of AB, BC and AC respectively. Now first of all we will find out the coordinates of P, Q and R. Now as P is midpoint of AB, so coordinates of P will be equal to 0 plus 2 upon 2 and -1 plus 1 upon 2. That will give us 1, 0. Now coordinates of Q, as Q is midpoint of BC, will be 2 plus 0 upon 2 and 1 plus 3 upon 2. Now R is midpoint of AC, so coordinates of R will be 0 plus 0 upon 2 and -1 plus 3 upon 2. Now after this we will find out area of triangle PQR. Now our second step, we have to also find the ratio of the areas of the given triangle. So area of triangle, we will find the area of triangle ABC, and at last we will find out the area of triangle PQR upon area of triangle ABC in order to obtain the required ratio. Question number 4, we have to find the area of quadrilateral whose vertices taken in order are given to us. Now vertices of a quadrilateral are given to us. Suppose ABCD is the quadrilateral. Now first of all we will find out the area of ABC, triangle ABC, and then area of triangle ADC, and sum of the areas of these two triangles will give us the area of quadrilateral ABCD. That means area of quadrilateral ABCD will be equal to area of triangle ABC plus area of triangle ADC. Thank you.